We use the flow of electricity in a variety of different ways. LEDs to create light, speakers to create sound, and even motors to create motion. But what if we want to store an electrical charge, hold it in one place? Well, to do that, we'd use this, a capacitor. They're one of the most common electronic components. Capacitors, or caps for short, store electrical energy, and this can be very handy in everything from power supplies to noise filter circuits. And they come in a really wide variety. Just to name a few, there is the classic ceramic disc capacitor, the handsome polyfilm cap, and of course the cylindrical tower of power, the electrolytic capacitor. And some of these electrolytics can be very large. But yeah. I decided to have a look inside a small electrolytic cap to see what makes it tick. Outside of the plastic coating lies a pretty thick metal shell. Inside that shell, I found a tightly packed roll. And that roll is made up of long strips of paper and two thin metal conductors. And that's all. It's a pretty simple design, but where did it come from? The history of the capacitor stretches back to November 1745 in Germany. While conducting an experiment, Ewald von Kleist received a shock from a nail he'd inserted into the top of a bottle. After further investigation, he found that he could store a charge in a handheld container of water. Now, Kleist did tell some of his friends and colleagues about his discoveries, but he wasn't the one who went down in history as the inventor of the capacitor. Less than a year later, a Dutch professor at the University of Leiden named Pieter van Muskenbroek developed a very similar device. It consisted of a jar lined inside and out with metal, and through its cork had a chain that ran down to the inner lining. A charge could be applied to this chain and then later discharged by connecting the chain to the outer layer. Muskenbroek's device became known as a Leyden jar, which is a basic capacitor. So the way a capacitor works is pretty simple. And it might make you think, gee, can't we make one? We can, and we will. To make my own Leyden jar, I used a plastic film canister. You could probably also use a pill bottle or similar plastic container. Some paste, tape is good too. Some basic wire, I used stranded 2 pieces. And some aluminum foil. First, I cut 3 pieces of foil, 1.5 by 4 1/4 inches, and thoroughly pasted one side. Rolled one onto the outside of the canister, nice and smooth, and then carefully inserted another inside, smoothing it with my thumb. Then, I stripped the wire and taped it to the inner foil. Cut a hole in the lid for our wire to go out, and made sure it fit all right. Then, I fixed another wire to the outside and wrapped the whole canister in tape. Once I had everything together, I made a connection from the outside conductor to ground on my faucet. An exposed water pipe would work too. I taped my wires down to make sure they didn't accidentally short while I was working. There are a lot of ways to generate static electricity, I decided to use a PVC pipe and a cotton rag. I connected the pipe to ground, and while rubbing the length with the rag, I let the center conductor rub against it, picking up a charge. Now, to discharge, I brought the two conductors slowly together right there. It made a little spark. Now, that little spark did demonstrate that a charge was held inside our capacitor, but I knew this setup could do better. I exposed a section of the center conductor and brought it close to our connection to ground. I taped them in place. Once the charge is strong enough, electrons should jump across this spark gap. And jump they do. Our little Leyden jar keeps working over and over and over. Well, as you can imagine, this caught on rather quickly in the scientific community. It wasn't long before others were making Leyden jars of their own and developing improvements. Benjamin Franklin discovered that it didn't have to be a jar at all. He could use a flat piece of glass with a flat conductor on either side. And beyond that, English chemist Michael Faraday developed practical applications for the capacitor when he was looking for a way to store excess electricity from his experiments. Faraday's work earned him the namesake of the capacitor's unit of measurement, the farad. A farad is very, 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 very large. You'll notice that most capacitors today are measured in much smaller amounts, such as a microfarad.